syarat. Nak kena cut ke? Ya.
Assalamualaikum, my name is Fatimah Sirah binti Azman, DF210094. I will present about institute summary and discussion. Okay, this project conducted by a group of 5 students and was given a task to design a truss bridge and will be test for 10 kg loading for a duration of 30 seconds without collapse. The bridge will be tested based on the lightness, least deflection, the creativity and buildability of the bridge model. Okay, first the student make the design according to the given dimension, then draw the layout of the truss. After that, calculate the deflection using LimPro software and by manual to compare the data, then build a sample model to obtain the quantity of statistics that have to use for each member. Finally, test the sample model at lab. All the factors that influence the strength of bridge also are analyzed.
Truss bridges are a type of bridge structure characterized by their open web of interconnected triangles known as trusses. These trusses provide strength and stability to the bridge by efficiently distributing loads. The analysis of truss bridges involves studying the forces and stresses within the bridge members under various loading conditions. Principles of structural analysis, including equilibrium equations, statics, and the method of joints or the method of sections, are applied to determine the internal forces and deformations in the truss members. This analysis allows engineers to optimize the design of the bridge, ensuring that it can withstand anticipated loads without excessive deflection or failure. Truss bridges experience different types of loads, including dead loads, live loads, and environmental loads. Analyzing these loads and their effects is essential for designing a structurally sound truss bridge. To analyze truss bridges effectively, engineers often employ computer-aided modeling techniques. These techniques involve creating a 3D mathematical representation of the bridge using specialized software. The model takes into consideration the geometry of the truss, material properties, and loading conditions to simulate the behavior of the bridge. In the design of truss bridges, several factors must be considered. These factors include the desired span length, anticipated loads, material selection, and construction constraints. The choice of materials such as steel or timber depends on factors like strength, durability, cost, and aesthetic preferences. Design considerations also extend to the selection of appropriate connections, joint types, and the incorporation of safety measures to ensure the longevity and stability of the bridge.
Assalamualaikum, I Nur Hazrin Abi Nabila binti Muhammad Zahiri, matrix number DF210035, would like to explain the objective and the methodology of this project. First, let us start with the objective. The first objective is to design and build the lightest bridge with the highest structural efficiency that can span a given opening, meeting the requirement as specified in these rules. Next is to make a creative and buildable model bridge and to test the strength and weakness of bridge that accommodate the load. Other than that, learn about planning and construction bridge and how about teammates and working in groups, and lastly, to increase our understanding of structural analysis subject.
Hi, Assalamualaikum. My name is Nur Hazika binti Muhammad. My number matric is DF210041. So for our project, for our bridge, the specification element that we use is the overall span length of the model is 1200 millimeter, and crease span between each supporting must be 1000 millimeter. The width is 100 millimeter. The height is 300 millimeter, and the bridge must be simply supported, which is the support is pin and roller support. There is no deck slab of the bridge, and the base area is 100 times 100 millimeter. So this is the view and layout plan for our bridge, which plan view, front view, and side elevation. The method that we use in our project for our bridge is first is scissor, cutter, knife, pencil open, ruler, measure tape, clip, and statistic, string curtain, and hot melt glue gun. So for the procedure that we use to build this bridge is first is we designing the wooden terrace bridge that we want to build, and second is sketch out design on paper, and next we sketch at AutoCAD by refer the bridge layout and design that required in this project, which is the length is 1200 millimeter, and the placement between edges is 1000 with 100 millimeter. The height is 300 millimeter, and support is the bridge is simply supported, which is pin and roller, and no deck slab, and the base area is 100 times 100 millimeter. And then after we sketch out is we take a scissor, cut the statistic to the size needed, and build the bridge. And next is build truss by connecting the stick with the second glue by string curtain and at each joint to make structure more strength. So the last one to build this bridge is finish and testing the 10 kilogram load at point A and B to the bridge for a duration 30 seconds without collapse. So that's all for our project for procedure and material, and also layout plan.
Next, we move to the methodology. First, we start with the procedure study. We were able to investigate how the design of the truss impacts the distribution of force by first looking at some antecedent research and examining the result of the studies. Furthermore, we have successfully discerned the various types of forces that are being exerted on the truss structure, predominantly encompassing tension and compression forces. The Warren Bridge that we use had several alterations and modifications made to it. For the properties of the material and types of adhesive used, it is essential to have a true comprehension of the characteristics of the Warren Bridge in order to achieve the greatest possible load-bearing capability of the structure. During the design process, careful consideration was given to the selection of joints for the bridge, considering the tensile and compression strength of the steel truss system. This particular truss system was chosen due to its relatively lower strength compared to more rigid material such as aluminium and steel. The selection of adhesive material significantly influences the structural integrity and load-bearing capacity of the bridge. There are many distinct kinds of glue, each of which has its own unique properties. Because the integrity of the bridge construction is wholly dependent on the quality of the adhesive that is applied. The particular brand of adhesive that is utilized is another factor that needs to be taken into account. For the model making and testing, the truss bridge design was meticulously drafted using AutoCAD software. In order to guarantee the utmost accuracy in the construction of our bridge model and optimize our operational process, it is imperative to implement measures that promote precision. Every structural element of the bridge was meticulously identified, labeled, and precisely trimmed to match the specific dimension outlined in the AutoCAD blueprint. By implementing this approach, we can effectively guarantee the precision of the positioning of every individual member within our truss bridge. Upon the completion of our truss bridge model, it was duly set aside for an approximate duration of 1 hour, thereby facilitating the complete drying of the adhesive. During the load testing process, it was imperative to establish the precise positioning of the hub prior to suspending the load. This precautionary measure was undertaken to guarantee a uniform distribution of the load across the entire of the bridge structure. Both the success and the failures were documented for possible additional investigation in the future. Lastly, for the progress timeline, there are a few steps to produce a bridge, which is first to prepare and buy materials such as skewers, hot glue gun and rope. Next, discuss the design that we want to choose based on the strongness and have an easier step to do it. The third process is casting the skewers based on the measurement given, which is 120 cm and divided into 6 parts, which is 8 cm times by 6 and 12 cm times by 1, and gluing the skewers. Connect the sticks that have been glued to build a bridge using a hot glue gun. After that, tighten each connection to make the joint stronger. The final task for the bridge is load testing and the bridge model, and then recording and analyzing the following component. Final submission is a full report that contains calculation and discussion based on the result.
Hi, Assalamualaikum. My name is Renaja binti Raimi and my matrix number is CF210011. And right now I'm going to explain a little bit about the analysis result from our test bridge model. The total of load that tests on our bridge is 17.33 kg, and it's already added with the span weight. By using manual calculation, we compared the result with the software result, which is we use the Limpro software. Here is the manual calculation that we've did. And the first figure shows the result of compression and also the tension of the member forces of the truss. And then the second figure shows the internal forces of the truss. So by using the value of area is 1000 millimeters square, and the modulus is 20 kilonewton over millimeter square. So the vertical displacement at joint D, we found it as 11.6 millimeter. So the result of the deflection at joint D shows in the diagram first, where the measurement is 11.60 millimeter through manual calculation, and then the second diagram shows the deflection at joint D, which is from the Limpro software result. So that's all from me. Thank you.
For discussion, the comparison of manual calculation result with data from Limpro software reveal that reaction to support and interval force. The value of deflection will decrease and the bridge will become more stable as a result. With a weight of 0.74 kg, make the bridge seem light but high in strength. Therefore, this bridge design is suitable enough to be built in real station to resist high load and is economic and easy to be built. Is it a good bridge because it can stand very high load, which is 70.33 kg. That's all for me. Thank you.